As aircraft have become larger and faster, the increasing air loads have made it impossible for the pilot alone to have sufficient strength to comfortably control the aircraft. The maximum permissible loads that the pilot needs to overcome to operate the controls are specified in EASA regulations. They are, of course, subject to amendment, but just to give you an idea, at the time of writing, the maximum continuous stick forces allowed were 10 pounds in pitch, 5 pounds in roll, and 20 pounds in yaw. You will see in another lesson that various aerodynamic devices can be used to assist the pilot. However, there comes a point where some form of power assistance is required. Power-assisted flying controls have hydraulic actuators assisting the pilot, while in fully powered systems, the entire load is taken by hydraulic actuators. A simple power-operated flying control system consists of 4 essential parts. They are a hydraulic actuator to move the control surface, a servo or control valve to control the actuator, a follow-up or feedback system to ensure that the actuator movement stops when the required displacement is achieved, and for a fully powered system, an artificial feel unit, as the pilot will not receive any aerodynamic feedback. Illustrated here is a schematic diagram of a hydraulic power-assisted flying control unit. It consists of a hydraulic actuator or jack, with a servo unit mounted on its body. The hydraulic actuator differs from those we have seen before in that the actuator body is not fixed, but is connected to the flight control linkage, and it is the actuator body which moves to hydraulically operate the flying control, while the ram is connected to the pilot's control column. There is a second connection to the pilot's control. This connection moves the valve in the servo unit. With the system in the situation shown here, that is, with the control column central and the flight control in its neutral position, the servo valve will be in a central position, blocking off both the hydraulic pressure and return from the actuator, producing a hydraulic lock across the piston. We will first look at how the system will operate without hydraulic power. When the pilot makes a control input, he will be attempting to move the hydraulic jack ram. Because of the hydraulic lock, the entire actuator will move, and with it the flying control. However, because of the mechanical advantage gained, the control surface movement will be small compared to the pilot's input. There will normally be sufficient movement available for the pilot to maintain control of the aircraft in the event of a hydraulic system failure. We will now look at the operation of the system with hydraulic power available. Once again, when the pilot operates his control, the hydraulic lock will cause the actuator body to move, and with it the flying control. Because of the position of its connection on the control column, the servo valve will move further than the jack body, so one port of the actuator will open to hydraulic pressure, and the other will be open to return. The hydraulic pressure will attempt to move the actuator ram. This movement will be opposed by the pilot, so instead the body will move in the opposite direction, moving the flying control. As the actuator housing moves, it gradually repositions the actuator ports in relation to the servo valve pistons until the fluid is shut off and movement stops. Control surface movement is therefore amplified in proportion to the pilot's control input. In this system, the pilot is still feeling the aerodynamic loads on the control surface and must hold the control in position to oppose them. If the pilot releases the control, these loads will return his control to the centre and bring the control surface back to neutral. Power-assisted flying controls are therefore reversible controls in the same way as those in a manual system. In a fully powered flying control system, all of the work in operating the flying control is done hydraulically. There is no direct connection between the pilot's input and the flying control surface. The system components are very similar to those used in the power-assisted system. The Powered Flying Control Unit, or PFCU, is the same, except that in this case the actuator ram is bolted to the aircraft structure. This means that the ram cannot move. The pilot's control only operates the servo valve. In our example here, the pilot pushes the control column forward. When the column is pushed forward, the servo valve is moved over to the right by the control linkage. This action opens the right-hand port of the actuator to hydraulic pressure, while opening the left-hand port to return. Since the ram is fixed to the aircraft, hydraulic pressure will now move the actuator housing over to the right, thus lowering the elevator. As the actuator housing moves, it gradually repositions the control valve pistons until they cover the actuator ports again, thereby cutting off further hydraulic supply and blocking off the return port. This creates a hydraulic lock in the actuator and prevents further control surface movement. This is a non-reversible system, in that the aerodynamic loads on the control surface cannot move it or the control column. The control surface is held in the last selected position by the hydraulic lock. When the flying controls are power-operated, some form of control unit duplication is necessary to guard against hydraulic system failure. This is often accomplished by having two powered flying control units operating each flying control surface. These units will be operated by separate hydraulic systems. Each powered flying control unit has a bypass piston fitted, which is normally held closed by hydraulic pressure. Should a hydraulic system fail or be taken offline by the pilot, then the drop in hydraulic pressure will allow the spring-loaded piston to open the bypass channel and so break the hydraulic lock in the actuator. This will permit the fluid to flow from one side of the piston to the other, allowing the powered flying control unit to follow the control movement of the other unit. That is the end of the lesson. You have learned that powered flying controls are operated hydraulically, that power-assisted systems are reversible, and fully power-operated systems are non-reversible. You have also seen that powered flying control units are usually duplicated, with each unit being powered by a separate hydraulic system.